Hey everyone, this is section 7.3, Path 090, Introductory Algebra. The objectives are to find the y-intercept of a line from the equations y equals mx plus b in that form. If we're given 2 points on a line, we should be able to find the slope. And given a linear equation, derive the equivalent slope-intercept equation and determine the slope and y-intercept. And then solve some applied problems involving slope. So we've done a bit with lines, and we've thought and talked about slope, and it's important because it describes the rate of change of the line, and lines are nothing but rate of change. So we often write them in the form f of x is equal to mx plus b. Indeed, if a function can be written strictly in that form, x to the first power, then it's what's called a linear function. And it's really common for us to take a line and rewrite it into this form. So let's rewrite the functions 2x minus 3y equals 9 and minus 4x plus 6y equals 3 into slope-intercept form. Let's start with 2x minus 3y equals 9. I'm going to subtract 2x from both sides, so minus 3y is equal to negative 2x plus 9. Okay, and then I think we got to divide everything by a negative 3. So y will be equal to negative 2 divided by a negative 3, 2/3 x, minus 9 divided by 3, 3. Great, and now let's do this one over here. Minus 4x plus 6y is equal to 3. And if you feel like it, you can always pause the video and work on the solution yourself. 6y is equal to 4x plus 3. Y is equal to, we'll just write it out, 4 over 6x plus 3 over 6, and then simplified and reduced, 2/3 x plus 1/2. So in general, we subtract that x over, and then divide by that coefficient on y. Take the coefficient on y, negative 3, and divide by it. Take the coefficient on y, 6, and divide by it. Okay. Oops. There we go. So we subtract the x over, divide by the coefficient on y, subtract the x over, divide by the coefficient on y. So we had 2/3 x minus 3 and 2/3 x plus 1/2. If we graph these in pink and purple, we can see that they're running in the same direction, right? They both have this 2/3 multiplying x. M is 2/3 in both of them. The slope is 2/3 for both of these lines. They have the same slope, but they have different y-intercepts. F of 0 is negative 3, and g of 0 is 0.5. So g is f moved up 3.5 units. So since these equations are both in slope-intercept form, we can read the slope and y-intercept directly from the equation. F of x is 2/3 x minus 3, has slope m equals 2/3. B right here is negative 3, so the y-intercept is 0, negative 3. In G, it has slope 2/3, m equals 2/3, and in this case, B is equal to 1/2, so the y-intercept is 0, 1/2. If we have an equation like 6x plus 7y equals 11, we can find its slope and y-intercept by rewriting it into y equals mx plus b form. When we do that, we get that the slope is negative 6/7, and the y-intercept is 0.11. And because we can just read them directly, we really like this form. We also like it because these two lines, we can see that they're parallel right away. And we can see that they differ in terms of their y-intercept. And if both of these values, m and b, were the same, we'd be able to right away tell that they're the same line. That's not always the case in other forms of a line. Slope. We can also always find the slope using the slope formula, take the change in y, and divide it by the change in x. Or if I was to give you some points, we could use that to find the slope of the line that passes through them. And we could then use that to construct some lines. Now, some applications use slope to measure steepness. We've done an example with the grade of a road. And numbers like 2%, 3%, and 6% are used to represent that grade of a road. So what does a 3% grade mean? It means that for every horizontal distance of 100 feet, that road rises or drops 3 feet. You generally tell the rise or fall from context. Slope can also be considered as a rate of change. For the roads, this is the vertical distance compared to the horizontal distance. The change in one compared to the change in another. For something like a population, it's the change in the number of organisms divided by the time that has passed. And this comes up quite a bit in the word problems. So a treadmill is 1.5 meters long. It is set to rise 0.13 meters or 13 centimeters. What is the current grade of the treadmill? We need to find the vertical change divided by the horizontal change. There we go. So I'm going to draw a quick little treadmill picture here. Zoop, zoop, zoop. So it's going to be we're just going to call 1.5 the horizontal here, even though we should probably use the Pythagorean theorem. These numbers are different enough. They differ by a factor of 10. It's not going to make a huge difference. And this vertical here will be 0.13. So for something like this problem, we're just going to consider this the vertical, consider this the horizontal, and we'll say that it is 0.13 divided by 1.5. Uh-oh, it looks like long division time, because we got to get a percent. We got to get a grade out of this. We can't leave it as a fraction. So that's going to be 15 dividing into 1.300, let's say. 0.0, let's see here. 15 times 6 is 90. So 15 times 8 is 120. 0, 8, 120. And bring down the 0, gets 100. What did we say? That was 6. Hey, that's just going to keep repeating. So I would say that this is approximately 8.67% to the nearest hundredth of a percent with 2 decimal places. Great. A treadmill is 1.5 meters long. It has a maximum grade of 15%. How high of a rise is this? Well, let's see here. Let's go back to our treadmill picture. Call that y because I don't know how high it is. And we know that the vertical divided by 1.5 is going to be 15%, 0.15. Oh, so we're going to multiply. Y is going to be equal to 0.15 times 1.5. Well, it's almost as if I picked these numbers because I know that the square of 15 is 225. We need 1, 2, 3 decimal places. 0.225 meters or 22.5 centimeters. So make note of that when you're looking at your ceiling and putting your treadmill somewhere. Don't bonk your head. A population of fruit flies increased from 2,000 to 50,000, my goodness, in 60 days. What's the average rate of change? A lot. Let's take 50,000 and subtract 2,000 from it, and we'll get 48,000. That's the change in the population. We need to divide that by the time. 48,000 in 60 days is, let's see here, 4800 over 6 is 800. So 800 fruit flies per day. And per, of course, is our big important division word. So fruit flies per day, numerator per denominator there. Okay. Use the graph to find the slope of the line. Well, we're given 2 points right here. And let's see here. The x increases by 1, 2, 3, 4, 5, 6, 7, 8. And the y increased by 1, 2, 3. 3 over 8. That's our slope. And that's it for this section. See you next video.